Hey there, in this video we're going to talk about functions. Python has several built-in functions. We've seen some of them before. We've seen print, we've seen absolute value. A couple others that'll come in handy are min, max, length, and sum. Those deal with sequences like a list or a tuple, or later on an array. So let's say we've got a list 1, 2, 3, 4. We can do, say, the min of L, and that'll tell us that the smallest value is 1. We could do the max of L. So you can probably guess the answer will be 4. We can check the length of list L, how many things are in it. There's 4 things in it. And we can add up everything and everything that's inside list L. Get a total of 10. So those are functions provided by Python, but let's look at how we can make our own function. The way you create a function is by typing def and then your function name. So let's just call it func. And then we give it its arguments. Let's give a function arguments x and y. Then we have a colon. We've seen this a few times already for like if statements and for loops. And then we indent for the body of the function, and then we put whatever we want inside our function. And we usually end with some kind of return statement. That's going to be the value that comes out of the function. Like for example, the max function must have a return statement that returns whatever the biggest thing is in the argument that's passed to it. So it's returning 4 in that case. For our function, let's do something real simple, like it just adds x and y. And if we had a function that actually just added its arguments, it would make a lot of sense to name the function add. So let's do with, say, sum equals x plus y, return sum. Another way we could do this is we could just say return x plus y, a shorter function. Okay, so we've created that. And let's try out our function. So let's open up our textual help here and see if it tells us anything about our own function here. So if I go with s equals add, let's just print out the result. Let's add 1 and 2, or 1 and 3. Okay, so here's the help we get. It tells us what the function looks like, but it says no docstring. What's going on there? So a docstring is a single string right after the function definition. So like if I just type in hello and run the cell down here, now we can see, oh look, it has a documentation string. Normally you would write information about how your function works, at least if you intended your function to be used by somebody else. For the most part, you're going to be writing very short functions. You can just use a regular comment to describe what it wants. You don't really need to write a docstring. This is more if you're going to write a function for somebody else that you'd write your documentation string. So if you're just wondering, like, where did all the information and contextual help come from? It comes from the strings right after the functions. So for now, we don't really have to have that. And let's just try out our function. Add 1 and 3, and we get a result of 4. Okay, now coming back to our function here. You might have noticed when I typed sum here, sum equals x plus y, sum is green. Why is it green? Well, it's because sum is already a special name in Python. It's already the sum function. So it's generally bad to reuse a name that's a Python name. Like if you type a variable name and it turns green, like, it's easy to do this, like max, min, length, those are all pretty common names. That's a hint to you, like, you know what, buddy, you probably shouldn't use this particular variable name. However, if we do that, our function still works, but more importantly, did we break the built-in sum function? Like if I sum L, what is going to happen now? And the answer is, it's actually going to be just fine. And the reason it's fine is because a variable that is inside my function is not the same as a variable outside the function. Remember, in Python, variables are just names. There's no special distinction internally between a variable that refers to a number or a variable that refers to an entire function. So as long as my variables are just used inside the function, those are called local variables. They have no effect on the outside. Let's try something other than the name sum. Let's just call it z. Okay, so outside this function, what would happen if I tried to print z? Well, what's going to happen is it's not going to recognize the name. Z does not exist outside this function. Let's fix that. Let's make z equal to 99. Okay, so now I print z. Z is 99. let's modify my function up here and tell it to also print z. So it's going to print the result and also return the result. Okay, so that's my function. And let's run, let's get this cell out of the way. Come up here and let's add 1 and 3 again. So it should print and also return the result. Okay, so here z is 99. What about outside? Z is 99. These are different z's. There is a z that lives inside the function, that's called a local variable, and then there's a z that lives outside the function called a global variable. And they are different. They both have the symbol z used for them, but they are different variables. A little bit confusing, so it's kind of better style to use a different symbol for things that are inside your function versus outside. But Python does treat them differently. They're in different places. They have different scope, is what this is called. Now, what if, let's try something else. Let's create a variable called constant. And I'm going to write it all in caps. And there's a good reason for that. That's sort of a style issue. I want to have a constant and its value will be 42. Now, what if I want my function here to use constant inside? So I want it to include constant in the summation. So it's like add and also throw in an extra 42 for fun. Okay, so if I redefine that and now I run it, well, let's see. 1 plus 3 is 4 plus 42 is 46. What's going on there? The difference here is I didn't say constant equals inside my function. I just used its value. So what will happen is Python is running this code, okay, and it's saying, okay, I'm going to do an assignment to this name. I need the value x. X was passed as an argument, so I know what x is. I need the value y. Y was passed as an argument. I know what y is. And I need the value constant. Do I have a constant locally? Looks inside the function. It says, no, I don't have one. Do I have one globally? Oh, yes, I do have constant globally. I'm going to use it. The reason I wrote this all in caps is because the convention in Python is if you mean for a variable that lives outside your function to be used inside, good style is to write it all in caps. Python doesn't care internally about how you spell it, but to a human who knows Python looking at your code, they'll recognize that you meant for this to be a global variable. Okay, now what if I want my function to change a global variable? How can I do that? Let's make a new function here. We'll call it changer. And we'll give it no arguments at all. Its only job is to change the value of z. Okay, so like I want, no matter what z is, I want to set it to 7. That's the only job of this function. So let's run the function. And then let's print what z is. Oh, so this didn't do anything. Why? Well, it's because what we just talked about. Z is a local variable, and I made the local variable z equal to 7. That's just local to this function. It has no effect on the outside. How do I make it affect the outside? I have to add a special line. I have to say, hey, I really want to change the global variables. So I'm declaring that z is a global variable, and that when I change z, I really mean I want to change the global z, not the local z. So if I redefine my function and now run this, now z is equal to 7, both inside and outside the function, because I'm using the global value of z here. Okay, now let's look at something silly. What if I say c equals changer, right? I'm going to pass the return value of this function and store it in the variable c, except this doesn't have a return value. I don't have a return statement. I don't have to actually write the word return. So what happens? Well, when I run this, you'll notice nothing printed out. Okay, well, what is c? C is none. None is a special value in Python. It means no value. And it's what you get by default from functions. So if your function does not have a return value, it will implicitly return the value none. We can see this also with print. So the print statement is a function. If I say p equals print, you're like, what is p? Well, if I print p, I'm going to say none. In fact, this is like what would happen if you print. The result is none, because the print function, it has a job to write down text on your screen. It doesn't have the job of returning a value, so it by default will have to return none. Now you may have noticed, looking over here on the right at the context help, here that we have some variable names like written for us as like equals, like the separation equals space. What's going on there is this is called a default variable. You can use the same syntax when you create your own function, to have a default value. So let's make a new function and let's call it add better. Okay, our add better function takes two arguments, x and y, and by default, let's make y equal to 42. And then it just returns x plus y. Okay, so if I add better 1 and 2, I'm saying I want y to have the value 2, and then that'll just give me the regular addition. 1 plus 2 is 3. But what if I don't give it a second value? If I don't give it a second value at all, what it's going to do is it's going to use this default value of 42. And so it's going to add 1 onto 42 and give me the answer 43. Okay, so we can use this to give us default values. So we have to be careful about how we do this. The default values have to be the last ones. So I can't say x equals 42, y is required. That's illegal. It tells explicitly, like, here's the problem. You have to have if you have required variables, they have to be the first ones. You're allowed to have all of these with defaults. So I could do 42 and 42. That's legal, but I'm not allowed to have a default variable followed by a regular variable. Okay, the last thing we can do here is when we call our functions, we can refer to the arguments by name. So I could call add better and say x equals 1, y equals 2. I'm being very explicit. I have to know what the arguments' names are to do this. So if I do this and call them out 1 and 2, it'll say 3. I can't like to say I'm going to call them A and B. That's not allowed because that wasn't their actual names. However, I don't have to put them in order. I can do y first. Typically, you use this if a function has a lot of default arguments and you only want to change one of them. So for example, let's come back here to print. We can see that we have some default arguments, separation, end, and file. Let's say I just want to adjust end. I want to leave the other stuff alone. So let's say I want to print hi. And instead of the end being a new line, I want to make end be 3 dots. So when I print this, instead of putting a new line at the end, it puts 3 dots. This is maybe more noticeable if I have multiple print statements. So normally these would all be on their own line, but here it's using 3 dots instead of a carriage return. So in this video, we've seen how we can write our own function, and we've learned about optional arguments and how we can call out optional arguments by name. We've also learned about the special value in Python called none, which represents having no value.